switch here. I'd like to welcome everybody watching on our live stream. I'm Drew Desker, I'm the director here, and it's great to have people watching. Again on our live stream. If you are watching on the live stream and you have questions for our presenter, put it in the chat, and then we can, at the end of his presentation, we can relay those questions to him. So we're fortunate enough tonight to have Vince Sochi. Vince has actually he's talked a number of times about drones, but things keep changing, things keep improving, and so I thought it was time to get sort of an update on what UAVs are about. And so I'm going to turn this right over to Vince.
All right. Thank you, Drew.
So we'll get you started here.
This,
okay, I need to. Nope. Okay, now it should work.
All right, great. I'm going to stand over here. I assume this is a reasonable spot.
Yep, that'll work.
Get this out of the way. Hey, so thank you all for coming out here, and thank you, Drew, and Kopernik for allowing me to come out and talk. We get to talk about drones and do a lot of events on drones as part of my role with IEEE, which is the largest technical society in the world, and we do a lot of educational activities. And drones and UAVs are a real popular one, so that's why we end up doing a lot for them. All right, so I just want to give also a shout out because there's a lot of kids here. We're doing an event here next month called Understanding Flying Objects, where we're actually going to learn about what makes objects fly. Specifically, we'll be throwing some of these around. These are discs, and we're going to learn what makes this fly, how do you control how it flies, and even better, we're building a 6-hole disc golf course around Kopernik, and the kids are going to be able to get out there and play a course. So keep an eye on the Kopernik news for that. That's coming up here real soon. So the agenda I have, and I could talk about this stuff for days. So I know Drew gave me an hour, so I'm going to do as much as I can in that hour.
Actually, the kids have got to go to school on Tuesday. So.
Yeah, that's fair. So I'll talk about drone technology, a little bit about flight operations, the applications where people are using them nowadays, the ever-changing regulations. There's a lot of new stuff going on in regulations. I'm active with the FAA in integrating UAVs into our national airspace system, and there's a lot going on with that. I'll share a little bit about that. So lots of great things we can talk about, time permitting. So when would you use a drone? Well, first off, I'm going to take one, and I'm going to let you guys pass it around, okay? This is one I built. Don't worry, it could be manhandled. I've dropped this from the sky a few times, not on purpose. But I'll let you guys look at it. Just be careful, the propellers can be sharp, so don't hurt yourself on it. Just pass it around so you guys can see it. That is a battery on there, so don't stick any metal objects into the terminals. But there's a couple of ways you can use drones. Drones are often used for business. They're used for pleasure. It's fun to go fly it. Some of you guys were out there flying with me before. A lot of people use them for business applications. We'll talk about them. And there's a lot of service reasons you would use them. Now, generally they're used where it's very difficult to go for the human to reach it. So think about inspecting that antenna tower out back. Or think about inspecting a bridge or a cell phone tower. Those are great places to use it. They give you very precise control. So if you want precise control of a flying camera, great way to do it. And you want to match the drone to the mission, right? So if you were to go into a toy store and buy a drone, you'd probably be buying like an Angle. It's a beginner. They kind of do some auto control work, but that's the kind of drone you'd buy in terms of the flight pattern. Another one that's very popular is the Horizon. So that's what I was flying here. It's full control. They tend to have auto leveling. So if you saw me flying it out there, if I let go of the control, the drone would hover. These two are both like that. But then there's acrobatic drones. The one I'm passing around is an acrobatic. This is another one of those. And they are very agile. They give you real full freedom. But if I'm flying this and I let go of the control, it's out of control. You know, I have to balance it with the control when I'm doing it. So this is more for things like racing. That one going around is more for like racing, whereas this is more for photography. So why would you use it? They're effective for missions like this, right? I mean, look at this guy right here. You got a couple of guys on a bridge way up in the air, right? That's a pretty hazardous activity, right? Wouldn't you rather do this kind of work? What's he doing? He's taking this mirror down here to look underneath this cable string, right? That would be a great place to use a drone. Again, over here, you're inspecting a bridge. That would be another great place to use a drone. It's often much less costly and much safer than using manned approaches. So what's inside of an unmanned system? So you'll hear these called drones. You'll hear them called UAVs, or unmanned air vehicles, UASs, which is unmanned air system. Generally, it should be called a UAS. This is a UAV, but to operate it, you need the whole UAS, because you need the system. But what do you need to operate a UAV? Well, you need an airframe, which is this big X frame here. You need a remote control receiver, which is generally these things. I'm sorry, they're the transmitters. The transmitters, the receivers are on the aircraft. The receiver is built into here. I don't even have it on here. The one going around has another piece coming out of here. You need an electrical power system. That's a battery sitting on there. You need sensors. This guy has ultrasonic sensors on it. Some of them have LiDAR. Some of them have radar even. You need telemetry. If you were out there flying with me, you saw that you could read on the phone the altitude you're at, how far away you are, things like that. The battery voltage, that's telemetry. You need a way to maneuver your controls. Typically, it's with these joysticks. You need a propulsion system. Usually, that's motors and propellers. Often, you have a payload. That's, in this case, it's the cameras. You need a ground control system. That's usually one of these radios. And on that radio, you'll have some sort of visual system. So the one I was flying, I had an iPhone connected here to give me a visual of what was going on. You have your telemetry, you have your remote control transmitter, things like that. So lots of equipment is needed just to fly this system. Well, what goes into it? This is a block diagram of a drone that we build. It's this one right here, the one that's going around, similar system as this. So what you have on it is a frame. That's this black part I said. There's a flight control board, which is this piece of electronics in here. When you take it around there, you'll see a board in there. It's real tiny, and everything is as tiny as you can make it, because weight is kind of hard on an aircraft, right? You want to make this as light as possible. And you want it to make it, notice how when you see this drone going around, notice how the size of the flight controller is within the size of the frame. That gives it kind of a cage of protection, right? But you have USBs and SD cards on it. And then over here is all the propulsion. So there is an ESC. There's 4 of them. It's under these electrical tape. That's the electronic speed controller. There's a motor, and there's a propeller, and 4 of them. And then, of course, you have battery and power conditioning on it. Then you have all the communications. So your communications with the radio, and then you may even have communications with goggles. So in this case, it looks pretty. Oh, I'm breaking your space shuttle here. In this case, you put these on, and you could fly kind of VR, flying your drone. So you have goggles and such. So that's great. That's good. So when you're building these drones and you're looking at how to select the one you're using, the mission profile matters, and the payload matters. The payload is really what you're using it for. What's the payload of this drone? Who can guess what I mean, it's a camera, right? The mission of this drone is to take pictures. So the payload of what it carries around is a camera. Sometimes a payload might be some infrared sensor or a heat sensor or something. There are border security drones that fly around and look for heat signatures because there could be somebody hiding somewhere. Or an Amazon package could be.
And for those that were in our light and laser program, we talked about infrared sensors and how they use it so there are companies that will go to buildings and say, okay, facilities manager, you've got a leak in this area, and that's a great use of that.
Yep. So whatever your payload is, whatever your mission profile is, where you're going to use it, will determine the kind of drone you're using. Look at this drone that's here. That payload is a camera, but look at all those propellers. Why do you think it has so many propellers? It has a lot of weight. That's a heavy camera, right? It also has a long flight time. So it also has to be very carefully, very steady. It has to be very precise in its maneuver. It's probably a cinematography drone. So then you pick an airframe, right? Now I list three of them here. An airplane, a traditional airplane with wings, or when it comes to rotors, a helicopter or a multi-rotor. They all have their pros and cons, but helicopters, and these are called multi-rotors, they have multiple rotors on them. Their benefit is that they can hover. An airplane has a very hard time hovering. So if you're trying to take photography, steady photography, hover is needed. That's why these drones are used. Although people are using UAVs, winged UAVs that are like airplanes, to do scanning operations. So you can do a glide camera move as well. So they all have their pros and cons. You pick the airframe that suits you. And then you pick the payload that suits you. Now, there's a whole variety of different cameras you could have there. You can see the kind of features that people care about nowadays. You do need it to be stabilized. Somebody made a comment out there when we were flying. They picked this up and they moved this around and they said, hey, the camera moves when I do this. And it does, because this camera is on a gimbal. So if you look carefully, it can move in 3 directions. That's because it wants to be level to take the picture, and if the drone moves like this, it has to stay level. So the gimbal has to be able to move the camera in 3D space. And then this is an image that you would see on, say, a phone or whatever your display is. And the numbers that you see in there, or in all the text, that's called telemetry. So that would be your OSD, or your on-screen display. And they call it FPV because first-person view means it's as though you're a little tiny ant on the drone, seeing where it's going. And so you're seeing it from the perspective of the drone. FPV, you're seeing it from the perspective of the drone. On-screen display means it has all the data and telemetry that you might need. So lots of different configurations. Somebody mentioned the Amazon drone. It doesn't look like this anymore. They have a couple different varieties. I've actually worked with Amazon on it. One of the issues they're having, well, let me ask you this. Oh, I'm sorry. What do you think is the biggest challenge with Amazon delivering packages via drone? Close. It's actually people stealing the drone. If you're going to buy a $12 pack of whatever you're buying on Amazon, but you have a $13,000 drone delivering it, right? They're worried that how do you protect the drones? They figured out how to get the package to you. They can fly it. They have to work on regulations. They actually figured out the security aspects of it, right? The idea is they want to give you either a placard or some way where you can check in with your phone, and they could make sure that you're there to get it. But what they don't want to happen is to give you the package and somebody take the drone. So they've talked about things like having a winch system where they would lower it and keep the drone out, and if somebody pulled the winch, it would release. But securing the drone package is hard. And by the way, that problem is now coming to the whole idea of having autonomous deliveries. So you might have seen the Domino's commercial with the Noid jumping around and the little van delivering your pizza, right? People are worried that what if somebody steals these vans, right? If there's nobody there to protect it. So technology breeds problems. But one of the ways you solve that is you have sensing on your aircraft. So lots of different sensors you could have. Radar, LiDAR, camera, ultrasound. By the way, same sort of sensors going on autonomous cars. If you look at what autonomous cars are doing, they have radar, they have LiDARs, they have cameras and ultrasound and GPS. So you're building the technologies for everybody on these UAVs. From frequencies, think about everything you do to the aircraft is done through a radio link, right? My video is done through here. Actually, let me do it with this one, just because it's clear. If I had a phone on here. My video is done through here. All my telemetry is done through here. And my remote control is done through here. Well, the frequencies are chosen based on the bandwidth of the data you're sending. So video has a lot of data. So you need a very high frequency to send that much data that fast. Whereas telemetry is very little data. It's just bits and bytes. You can send that on a very slow frequency. And they're spread out so that you could run all those radio signals at the same time. So these are some of the tools you would use to run it. These toy drones come with kind of toy remote controls. We have a whole bunch of those. We actually ran a kids workshop with these. We found out that kids are pretty rough on those. We burned a bunch of them. This is a setup we use for the Build-A-Drone program. That's why I have this Tyrannus radio. This is from that Build-A-Drone program. That's from our drone operator course. That's these Phantoms and the radios that come with that. And then the Mavics are for our application courses. So we've been running with that as well. Now these remote control systems, that's your connection to the aircraft. So it consists of the transmitter and the receiver that's on the aircraft. The green one still going around somewhere? Oh, it's right here. You guys all saw this? Okay. So it kind of looks like a bug with these antennas, so it's often hard to see. But this is actually the back of it. The camera's the front, right? Because that's what you're out there doing. But this has a couple of different transceivers on it, right? This one is for your video, and this one's for your remote control and your telemetry. So a couple of different transmitters and receivers on it. This is a transceiver because it sends the data to you. This is a receiver, but it's also a transceiver because it needs to send the telemetry back to you. There's multiple channels on it because if you had a bunch of guys out there on a drone field running, you don't want to step on each other. So these radios generally have ways to change your channels. So, and you can program these to do all kinds of different things. This looks old. This looks like old technology compared to some of these, right? But this radio is phenomenal. This can do everything you'd ever want. You could program it to set up for different drones. I could set this up for this drone and tune this drone different than that one, and then pick the different drones I want to use. This is an amazing piece of equipment. When it comes to batteries, I use these LiPo batteries. Everybody generally has their own kind they like for each drone. They're generally proprietary for these commercial drones. So this is a DJI battery. And if you look at a drone, a commercial drone, about a third of the cost is the drone. about a third of the cost is the camera, and about a third of the cost is the battery. The battery is a very expensive component because they know you're going to buy a bunch of them. And generally, battery technology is pretty expensive. But these guys right here are just these commercial batteries you can buy for a couple bucks. So these are the ones I use on these builder drones. The funny thing is, these ones don't get much flight time. I probably get about 5 minutes of flight out of this drone with this battery, whereas this guy I get about 20 minutes of flight. I also fly this one a lot rougher, so that's part of it. But a lot of it depends on the chemistry and the stack up of the battery. So you can see some of that detail there. When it comes to the motors, different motors give you different performance. These are brushed motors. These are brushless motors. And a lot of that depends on the kind of drive you want to use. But you select the motor for the multi-copter you're using. So the biggest driver for the size of the motor, well, two drivers. One of them is the weight of the aircraft, because as you can see here, the thrust you need to get out of a motor depends on the weight of the aircraft, some safety factor you put in for it, and then the number of motors you have. Not everybody has 4 motors, some have more or less. But then the other thing is how fast do you need it to accelerate. So these motors are actually pretty strong relative to this one. Right? This Mavic has these little tiny dinky motors, whereas this one has these bulkier motors because I want more power out of this one. This is a racing drone, so I need a lot of acceleration. This is how you would wire an aircraft together. There's a power chain up top. You can kind of follow this picture. Flight controller with all the sensors and telemetry that you'd have. So you have the red being all the power, the blue being all the data, and the orange being all the communication. These are the actual parts that we put into these builder drones. The flight controller and the video transceiver. And you can see there's a good number of wires, but not overwhelming. The flight control, most of the wires go out to these ESCs and then to the motor. So we just solder them up. 3 wires there, tape the ESC down, 3 wires out to the motor. Piece of cake to put those together, but that's kind of how we build those racing drones. Now when you get to the camera, there's a couple of choices you could have. Generally we use these little tiny board level cameras that you see right here because they're cheap and they're good for these FPV. You kind of keep them at a fixed location. But when you get on these commercial drones, you're investing pretty heavily in that camera because that's what is there. That's what this drone does, right? The purpose of this drone living is to take pictures with that. So you invest in getting a real good camera there. So you could use GoPros, you could use bulk cameras like that. But what I want to show here is, if you want to walk into Best Buy, where would you go to find a drone? You'd go to the camera section. Because they don't call this a toy, right? They call this a camera that flies. It's not a drone that has a camera. It's a camera that flies. So most of these electronic stores treat them as cameras because it is the most important part of what you have. I mentioned about the gimbal and some other challenges with cameras there. And when you tie these into a first-person view system, you need a video switch to go from your display to your goggles if you're running with goggles. And this is an old set of goggles. Most goggles now they don't have this big box on the end of it. They're real compact. But you'd put antennas on it here. I don't have the antennas on it, but these are your user interfaces. You press the buttons you need to tune into the right channel, and they'd be your user interface. By the way, if you were to fly with goggles, you still, by regulation, you still need somebody to have visual line of sight on the drone. You can't fly goggles alone by rule. So there's some FPV goggles. The other thing a lot of people do is they take an FPV monitor, which I was using with my phone. Sometimes put a shade around it to keep the glare off. But that's how you'd have your visual interface. So let me talk about some flight dynamics here. You saw these drones going around. If you were to pick up a control like this, some of these I showed out there, this is a mode 2 control. So your left stick has two functions. It is your elevation. You push up or down as your throttle up or down. That's going to raise and lower the drone. And then the yaw is left and right on the left stick, and that's going to turn it. So you would take your drone, and if I push the left stick up, the drone does this. I push it down, it does this. I push it left, it tilts this way. Push it right, it tilts this way. On the right stick, you can see it has your pitch up and down and your roll left and right. So if I pitch it up, it's going to actually go backwards because it's going to pick this way and go this way. If I pitch it down, which is pushing the stick up, it's going to go forward. And rolling, roll left or roll right. So the right stick is how you move it along the horizontal plane, right? And your left stick is how you move it along the vertical plane. Make sense? So let me ask you this. This is where it gets a little funky. How does the drone move left, right, forward, or back? By tipping? How do you tip a drone? Because remember, the only thing you have as a pilot, the only thing you have is this, right? I have a couple of joysticks, that's it. Yep, so if you look carefully at these drones, one thing I want you to see is that the propellers look different. So if I line these side by side, do you notice anything? This propeller is different than this propeller. They're pitched opposite, right? So this propeller is intended to go this way. If you look at here, this says, the one in the upper right picture here, the top left propeller goes clockwise, the top right one goes counterclockwise. So this guy goes counterclockwise, this guy goes clockwise. And the reason they spin in different directions is because they add torque to the vehicle. So if this is my drone and I spin these propellers faster than I spin these propellers, what's it going to do? These are going to lift more than that one. So it's going to go that way. If I spin these propellers more than that, this is going to lift and it's going to go that way. If I spin these faster than that, it goes that way. Spin these faster than that, it goes that way, right? So you could change the angle of this drone by spinning propellers at different speeds, right? How do I make it spin? Again, the only thing I could control is the speed of the motors. How do I make it yaw? So yaw is make the drone pivot. No, you don't change this. Nope. Actually, you do have to be very careful when you put these on. If you put them on wrong, like if I swap these two propellers, the drone would not fly. So to make it spin, I said you have to fly these faster than this to make it go that way. So you pick a adjacent pair and fly them faster than the other pair, and you'll do that. To make it spin, you take corners. So if I spin this guy faster than this guy, it'll spin this way, right? And the reason for that is a funny physics term, where if you spin this propeller, it has an angular momentum on spinning the drone the opposite way. So this guy's trying to spin this way. As it spins this, it tries to force the drone to spin this way. So if I spin these really fast, the drone's going to spin like this. So That's the way you end up moving the aircraft. All you need to do is change the speed of the propellers, and you can make it go in any direction. So I talked about all the control sticks and the surfaces, and we did all that. These are a couple of different frames that you could use. Not every one of them is a quadcopter, and even the quadcopters come in different flavors. Some of them are octo or hexa copters. Some of them have motors on top of each other, like that X8 that you see up there. So they have 2 propellers on each of these arms. So the flight control, we talked a lot about the flight controller. How am I doing on time, Drew? What time is it? Okay. All right, so when we get to flight controllers, there's the way you tune a drone. The most fun part of these drones is tuning them. When you build this, the first time you power it up, it's going to crash on you. I tell everybody that when we build them, because I don't want them to get upset. But the first time you fly it, it's going to crash. And the reason is you haven't tuned the flight controller. The flight controller doesn't know the weight of the aircraft, and that's going to change depending on the kind of batteries you choose, depending on all these design choices you made. It doesn't know, I mean, you've got to tune the angle of your camera. This camera right here is too loose. I need to tighten that. Or else you won't be able to see where it's going, because when this flies forward, it's going to be tilted. So I needed to tilt that up. If it was tilted down here, you're going to see the ground. You're not going to see where you're going. But the flight control doesn't know the weight of everything. It doesn't know the performance of each motor. So it doesn't know how fast it should be spinning all these things to do what you want. So in a flight controller, we call it a PID controller or a PID controller. And there are gains that we adjust so that when you give it a commanded state, it's going to read the sensors of where it is, determine an offset. It's going to run a control loop based on 3 gains, proportional, integral, and derivative. It's going to drive the output to put the aircraft in a new condition. You're going to sense that new condition, and you're going to compare it to your commanded state, and that's a closed loop control. So it's going to keep updating the output until the new aircraft condition matches the commanded state. So when you look at a PID control, the reason there's 3 of them there's a proportional, there's an integral, and there's a derivative. And the tuning of those gains are going to help determine how fast this loop can converge. So a lot of the fun of working these drones is in tuning those controls. But it is a process. We end up doing that with some radio links that we have. We've talked about the different flight control peripherals, all the different things you can have, GPS and compass, all these different sensors are on your system, the different telemetry data that you might end up having. I had a conversation outside with some folks about what it means to have a flight crew. And when it comes to a drone or a UAS flight operations crew, there's actually several roles. When I'm out there flying, it's generally just me. But if I'm out there doing a commercial program, I'll usually have a few people. And the reason is there's a lot of things that have to go on. So let me share some of those roles. This guy right here is the most important guy in this whole picture. It's called the remote pilot in command. And the FAA cares about this guy. Doesn't care about anybody else. This guy bears all the responsibility of everything going on out there. But he's the guy who has to manage this whole team. There's going to be a person manipulating the controls, or the MC. There's going to be a ground control system, which is usually your radio, but that's whatever is communicating to the drone. Sometimes that's an entire room full of computers. There's a payload operator. Often the person controlling the drone or the UAV is different than the person controlling the payload. Where would that be the case? Think of some applications where that would happen. Military would be one, right? Usually if you're filming a drone, using a drone to film a movie, because the camera shot is too important to be disrupted by the person flying the aircraft. The aircraft has to fly safely, but that person managing the camera has to focus on getting the right shot. So often these are two different people. Sometimes there's somebody else who's doing the flight operations and communications back to whoever's in charge of all that. But over and above that, besides the remote pilot in command, the second most important person is the visual observer. Somebody has to have their eyes on the aircraft. Now, when you outside and fly one of these drones, you're serving all those roles. But you have to always have somebody with eyes on the aircraft. So if you're out there and somebody's flying it a half mile away, you need to have a VO. Now, this is for commercial use. Military has a completely different set of rules. But a lot of different roles in that crew. Any questions on the drone technology before I get into some of the applications? Go ahead.
Replace the mechanical payload with software that will rotate the image for you, which would be lighter and kind of do the same thing.
It could, except it has to be in real time, right? So when I'm out there flying, if the camera were fixed, right? If the camera were fixed, and I fly the drone like this, coming back to my camera to my display in real time, that has to rotate back to where it was, right? Yeah, there could be a delay, and sometimes that delay could cause flight issues, right? It might, yep. Yeah, gimbals aren't that expensive to make though, so, and they're relatively light. All right, so let's talk about some of the applications. Oh, I didn't want to rush through that. Any other questions on technology? All right, so let's talk about applications. These are the top markets right now that are using commercial drones. Some of them are pretty obvious. I'm sorry, I'm in your way, aren't I? I'm in everybody's way. Do any of those surprise you? I mean, a lot of them are photography based, right? So somebody go and do and get a photograph of something, do an inspection of something, for instance.
Warehouse inventory. That I wouldn't think about that.
Yep. So drones are scanning. You know, it's not just a camera. People are putting like barcode scanners on these, and you're flying around and identifying where things are in your warehouse. So lots of cool things. I think the 3D mapping is kind of funny because you can take a drone, and if you had a LiDAR or a radar on it, right, I could fly this around this room and get an entire 3D map of this space. So one commercial company I know is taking drones, and with some software they have, they can fly into a building that's been damaged by an earthquake and go in there and scan the whole thing to get a 3D image for the rescuers coming in to find out not only where people are, but how to get around in the building. So if you think about an earthquake happens and there's a bunch of rubble, you could send a drone in there to do a whole 3D map and just fly around automatically and map the whole building and then come back, and then you could go in there with the insight of what's going on in that building. So you're not just going in blind, you're going in there with a real good image. So first responders, it's a way to get out and identify where a victim is. So a camera, you could, if there were say there were an earthquake, and you go into a city that just had an earthquake, and you flew around to scan, visually scan for people, or do a heat signature for them. The other thing that they could do is they could deliver medical supplies, right? There was a drone application where they go out, and if somebody falls into a, falls off a bridge, they can go and deliver them a life preserver. They can. So lost people, again, heat signature is a great way to do that. They've had people that have gone out in, I don't know if it was the Adirondacks or some other natural preserve, but you can go out and find not just wildlife, but missing people. Yeah, right. A bear would be a false positive, right? This is one this is actually a roof inspection I did. I had a roofer come help me, do my roof, and I was real worried about some areas where water was coming in. So water was coming in this area, and I wanted to get, when he did the roof, before I paid the guy, I wanted to make sure that those areas looked clean. So I did a roof inspection, flew it around and checked areas. I had to ask him about these. I said, what's all this? Are you missing shingles? But apparently that's the way you do it. You got to tar outside that stuff. But I don't know. I'm not a roofer. If any of you guys are a roofer and you tell me that's bad, let me know. But he assured me it was good. But I was most concerned about this area here because that's where we were getting watering. We did this quick mind map where I was working with some drone and UAV enthusiasts and asking them the kind of things that they do. So we put this map together, and I ran out of paper before we ran out of ideas. And these are some of the areas that we looked at. Obviously, photography and videography are the big ones. Real estate's growing, managing land and things like that. But I was really surprised at some of these. Disaster relief, we mentioned a few of those. The big areas where we're seeing a lot of money flowing right now is in agriculture. They're using drones to do not just visuals, but they're using drones to spray pesticides. They're using drones to actually take action on the crops. So I think it's pretty interesting because that's where they're seeing a lot of the money going. Yeah, so you think about if you're spraying chemicals onto your plants, fluid's what, 10 pounds a gallon roughly, right? So if you're taking a bunch of gallons out doing that, that's a pretty heavy payload.
As I recall, like some of those displays at the most recent Olympics, those aerial displays in the beginning and at the end.
Oh yeah, where they showed the Earth.
Are all drones.
Yeah, that was. I think what did I hear? Was it either 800 or 1800? I can't remember, but it was hundreds and hundreds of drones doing that. I just thought it was funny because as a pilot, I'm not allowed to fly 2 drones at the same time. You could only be an RPIC for 1 drone at a time. I'm like, how the heck do these guys get a license to fly 1,800 drones?
And then how do you do the frequency? The frequency coordination for each drone has to have its own separate communication channel, including now turn on the red light, now turn on the blue light, or whatever.
Yep.
Yeah.
Yeah. You're right. There's that was a fantastic show. If you haven't seen that, by the way, Google the Tokyo opening ceremony, and it was a shame that there weren't more people there to see it, but it was pretty fascinating what they did with those drones. I'm not going to get into the nefarious uses because I'm not going to condone that kind of behavior, but I will list that people are using drones for bad reasons, which is one of the reasons the FAA has to be so restrictive on use. Because it's not just us taking pictures of our grandkids or us inspecting cell phone towers. It's people who are doing bad things. People have delivered drugs on drones. They have the thing with doing that is there's no line of sight back to the person who's controlling it, and that's the hard part. For me, if you're doing this the right way, you take your drone, you register your drone, and when you register it, you put your registration information on the drone. So if I ever did something wrong and this drone crashed into something and a police officer picks it up, he could track me down because my information's on the drone. Bad guys, of course, don't do that. So that's one of the challenges we have with drones. And one of the applications for drones for good guys is called countermeasures or counter drone technology. And we're working on technologies to defeat these kind of nefarious activities. There's entire businesses on how do you stop a drone that's rogue? How do you stop a drone that's out doing bad things? And there's plenty of opportunity for that. So I will say this. Any one of you can go down, throw $700 on the counter at Best Buy and buy yourself a super nice drone that will do all these wonderful things that you want. Problem is, if you decide to start using it to make money, the minute you have a commercial use for your drone, you need to have a license to fly that drone. So what constitutes a commercial use? Well, if Drew hired me to take pictures of Kopernik and he paid me $1 for a picture of Kopernik, that's a commercial use. I would have to have a license to do that. If you use your UAS to provide any contracted services or professional services, or even taking pictures at a wedding, right, that you're going to sell, those kind of things are commercial uses and you would have to have a license. To be strict, to be absolutely strict, to post your YouTube video, you supposedly should have a license. Nobody does. Don't sweat it. But technically, YouTube could pay you if you had 1 million views of your, whatever you videoed with your drone and posted it on YouTube. So let me talk a little bit about the FAA regulations. There are a lot of commercial regulation challenges, not only in you doing good activities, but some bad guy doing bad activities that they want to protect against. And the FAA has this funny balancing scheme they have to do, right? They want to give you the freedom to do everything you want as a hobbyist, right? If I'm a hobbyist and I'm just flying around taking pictures of things that I'm interested in, I should have the freedom to do that. But like if I'm also going out there and fly over an NFL football game, they want to restrict me from doing that because I could be a hazard to other people out there. So historically, what they use for commercial aircraft is airspace allocation. So you might have areas like this where it's a predefined area that you can fly and do whatever you want in because you're doing model flying. We have some of those near here. But generally, when you get out there in everyday space, there's areas like the airport that are very restricted. You can't go and fly a drone in an airport. There's urban areas where they want to protect you from damaging other people. But as you get out to these more rural areas, you get more freedoms. So we'll talk about some of that airspace. But somebody asked me about how high I could fly that. By law, I could only go up to 400 feet. Because once I get above that, I'm in a no-fly zone. And legally, I'm not allowed to fly up there. I mentioned about your registration. If you have a drone, if it's more than 55 pounds, it's an aircraft. It's not a small UAS anymore. Less than 55 pounds and more than 1/2 pound, you have to have it registered. You have to have a Part 107 or a certification license to fly it. There are a bunch of rules. I'm not going to go over each one of them, but there's operating guidelines for your crew, for you as a pilot, for your license, all kind of regulations you have to file. I had a story out there. I talked to somebody about if I crashed my drone into somebody's car, I have to report it to the FAA within 10 days, and they would investigate me just as though I were flying a jetliner for Delta. Funny thing is, you can't carry any hazardous material, including lithium batteries, except the lithium battery that's you're flying with, which I think is hilarious, right? I could fly that lithium battery because it's powering me, But I can't take this drone and bolt the battery on the bottom, tape the battery on the bottom, and fly like that, right? Same battery, but I don't know. That's the rules. I won't go through all this, but there's plenty. If you looked up knowbeforeyouFly.org, you'd see all of these. You have to yield right away to other aircraft, other pedestrians, things like that. You can't drink and fly. Lots of regulations. I'm not going to go into all of them unless you're interested. But I did want to show the wedding cake picture. FAA Part 107 is the license you have to get to fly commercially for drones. But when you look at the airspace, depending on where you are physically on the air map, you may have different rights to fly. So if you're in Class G space, you generally are okay. Get to Class B, C, D, you're not allowed to fly in these spaces. Class A, definitely not. Why do you think these restricted areas are in like an upside down wedding cake? Why do you think? So, just to clarify, I cannot fly in any of this yellow, but I can fly here, right? I can fly here, but not here. Why is that? No. Why? Yep, that's right. So if this were an aircraft and it needs to land here, it generally is going to be up here in Class A space, which nobody can fly in, right? But as it comes to this approach, it's going to come into here, and then to here, and then to here. So that's why this expands as it goes up, because the aircraft coming in is coming down that wedding cake. Does that make sense? So it's all about keeping that space prioritized for aircraft. So this is what a map would look like. This is our map right here. Let me see, where are we? I live out here. So that's Tri-Cities Airport. We are, where'd you say, down here? Yep. Yep, so you can see the wedding cake. See the wedding cake? I mean, this is the top one. As you get down here, where are you at? You're at the Greater Binghamton Airport, right? That's a small tier. This is the next layer. This is the next layer. So here you can fly 400 feet. You're fine. You can't do that here, right? Within 5 miles of that airport, you're not allowed to. Make sense? As a pilot, to get your license to be a drone pilot, you have to know how to operate these maps. And there's a lot of information on there. Too much to go over right now, but there's a ton there. You can see altitudes that you care about. You can see frequencies, all kinds of different informations on that map. So I mentioned that I spend a lot of time working with the FAA on the national airspace. And how do we integrate into the national airspace? Because what's happening is there are more and more applications that are becoming mainstream. And the FAA realizes we have to get them in there. So we want to get them in, but we have to get them in safe. So we're looking at a variety of ways to do that. There's a lot of debate going on between the regulators and the pilots and the recreational hobbyists. We're trying to find a way to get there. It's going slow, but I do want to say the FAA does have our best interest. What we need to do is instead of fight, we need to get aligned and work on our path forward. And one of the ways to do that is drone technology. Drone technology is growing, and the sensors on the aircraft are getting fantastic. So you could sense a lot of information and perceive the world around you. And the processing in here is allowing you to think and evaluate and coordinate and decide. And then the actuation on this allows you to act and move and respond and execute. So the sense, think, act cycle is getting more and more precise. And I would argue that it's very difficult to say that You need to have somebody piloting an aircraft to have the same level of situational awareness and control. And that's been the big hurdle, because if you think about a piloted aircraft, you have a pilot in the cockpit that can see everything and can act on the aircraft. The FAA doesn't believe that a remote pilot has that same situational awareness or control. And that's the argument we're trying to get to. So the policy is growing, but technology is moving faster than the policy. And that's actually been a blessing and a struggle at the same time. The applications are stretching the regulations. We need policies that evolve and maybe leverage all of this new technology we have growing. FAA has taken some great steps in the right direction. This is one of them. They have the UTM Pilot program, where they're looking at how to use the drone pilots to coordinate with the rest of the FAA national airspace. And it could be everything from, one guy running a drone here, but he has to talk to an entire airport worth of data going on, the whole USS network, your FIMs, all of these different areas that are out there that we need to talk with. So from a drone technology standpoint, this drone technology is growing. We're getting more and more capabilities to the average user. I remember the first aircraft I flew was a little model plane. It took me forever to build that thing. It was a little model kit I had as a kid. I flew it and had no idea how to control it. I crashed it into the house, and that was the end of my airplane, right? It took me longer to build it than I ever owned the darn thing. Now you can buy these commercial ones that have far more capability than anything we've ever had. And it's easier than ever to fly it. Some of you guys were able to fly with me today. You saw it's not that hard to get control, and especially the fact that you could let go of the control and it would hover is fantastic. So kids now can fly these drones right out of the box, which is fantastic. And because of that, everybody's doing it, so applications are coming that we haven't even thought of yet. My daughter had a drone deliver her coffee once. It was a $30 coffee, but she can tell everybody that a drone delivered her coffee. So all kinds of applications are coming. The regulations have to keep evolving for safe use and freedoms for everybody creating those applications. And it's going to be very important for the UAS community and the commercial aviation community, meaning the pilots that are flying airplanes and the pilots that are flying drones, to work together, because they're kind of fighting right now, right? Pilots flying aircraft want to keep drones on the ground because they don't trust them. Pilots flying drones want to be able to integrate into the airspace because they want to be able to use it for their applications. So that's about it. We do a lot of these. We've worked with, in my business, we've worked with a lot of drone and UAV operators. We're also working with some of the urban air mobility. They call it UAM, where it's, think about a drone that's big enough to carry 5 people, right? A pilot and 4 passengers. We're working with them, and one of my customers, their name is Joby, J-O-B-Y. They have really gone a long way to working with FAA to get the regulations in place for them to do it. They are being the most proactive with getting that. And I'm confident that we will see urban air mobility happening real soon. Technology already exists. It's not hard to do it. It's hard to regulate it. And that's what we're struggling with, but they're being proactive with that. So I'll stop there and take any questions.
Oh, we do actually have a question from the one of our people on the live stream.
Okay.
Nicholas asks, when does a user need a permit or a license other than for commercial purposes? What is the youngest age you can obtain a permit or license? And he thanks you for the presentation.
Okay. So the youngest age to get a license, let me clarify it. Drew, can you go back to the picture of the crew?
Oh, sure.
Yeah, you have to be 16 to be a pilot in command. You do not have to be any age to be an MC.
Whereabouts?
Back more. I might be able to find it.
There you go.
Let me see if I can. Right there. All right. So remember I said this is the guy who's responsible for everything. That's the guy the FAA is counting on being the responsible pilot in command, right? Remote is what the R means, but it's really the response. He's accountable for making sure that that activity is safe. This person can be anybody he or she thinks is capable of doing that, but he's responsible for it. Okay, so if I have a 9-year-old granddaughter, she flies this all the time. We're down in Myrtle Beach. She flew this around Myrtle Beach. I was the RPIC. She was the person manipulating the controls. So to that question, you have to be 16 to be an RPIC. You can be any age for any of these other roles. And the question was about commercial.
Yeah. When do you need a permit or a license for something other than the commercial purposes?
So today, to be a hobbyist, you can go fly this around your backyard without a license. So if I'm just taking pictures because I think it's fun, or if I want to build a racing drone and go race it around the woods, I can do that without a license. The minute I become a commercial operator is when I start accepting money for what I'm doing. So if I took pictures and sold them, I'd have to. That's a commercial use. So right, the minute you use it for commercial.
So like I've seen drone racers that really scream around various places. I'm assuming those people, they may not be paid for it, but something like that, you'd have to be licensed.
Yeah, generally it should be licensed. By the way, getting a license is not a bad thing. It helps you be a safer and more knowledgeable operator. We did a drone program. I mentioned to you guys. We did a drone operator course. We charged $25 for it, and it was 6 weeks for the course. And they used these drones, and it was hands-on. It was, 25 hours of classroom, 25 hours of field work, and they all got drone licenses at the end. The fastest I've seen somebody get a drone license is one afternoon, where he decided he was going to get it, he made his appointment, he read the book, he went and took the test and passed. So it's not terribly hard to get your license. I'm convinced it's a way for the FAA to track you better, right? Because you're going to get a license, you're going to be registered, all your drones are going to be registered. I think the FAA really likes the fact that I register these drones. The FAA knows everything about this drone that they need to. So I think it's good overall for the community to be licensed.
All right. Any other questions? Well, you've obviously done a extraordinarily well done job.
Thank you, guys.
So, thank you, Vince. I'm assuming I haven't been out recently, but when I was out, Jupiter and Saturn were beautifully in our southwestern sky. I'm going to guess the moon. I know the moon is set, so we should be able to even see the Milky Way. So we've got at least one scope in the yard, which is actually our special scope that we purchased that is actually wheelchair accessible. Not that anyone is here with a wheelchair tonight, but so you can check that out. But also, so check in our 6-inch and our 14-inch. We'll have some at least those two objects, and we may be able to even look at some galaxies and globular clusters afterwards. So thank you again for coming.
Thanks, Drew.
So, is it going to take like a terrorist drone incident to get the FAA to